So if you're watching this video online, or if you weren't here in the last session, write down this URL, and you could use this URL, and it'll take you to all of the resources you need to learn Golang well. And yeah, having a clear pathway is super important. So just make sure you have the URL or take a picture of it. And we just did another session. If you missed that session, you can use this, and it'll take you to my YouTube account. When you get here, it'll take you to a document that has a bunch of links on it. And one of those links will take you to my YouTube account, where you could find Silicon Valley Code Conference, Golang, or something like that. And you can watch the first video later this evening or wherever. I just need to make sure I actually hit record. I am recording. That's good. All right. How many people didn't see the last session? Just show of hands. Cool. So what we're doing is we're just kind of looking at how do we do web apps with Go. And I have a pretty clear pathway laid out with code samples from the ground up, building HTML pages dynamically using templating. And that's what we did in the first hour. And in the second hour, we're going to take a look at creating TCP servers and HTTP servers, and then App Engine a little bit. Okay, so that's what's lined up. And at the end of this presentation, one of my mentors in the Go programming language is Bill Kennedy of Arden Studios. He's one of the largest community builders, and he's also a really great coder. And so he's just written a book, and this is his book. And this is one of the best books you could read for learning Go. I spoke with him via email. We emailed, and I said, hey man, I'm doing this presentation. And he said, give my book away to everybody, but get their emails. You can email it to them, and then send me their emails. And so if you want a copy of this book, afterwards you can come up, and I don't want to show this. You can sign up. I probably already did though. You can sign up for his book, and we'll email you a free copy of the book. This is being published December 2015. I've looked at pretty much all the material that's out there on Go, including books that were written in China and translated to English, which is kind of an interesting experience. And trying to learn a programming language with a book written in Chinese and translated into English, because we talked about that the first hour. But yeah, so afterwards come up and you can sign up for that book. So that's the resources, that's the book, and we're just going to jump back in where we left off. I don't need that anymore. So there we are with all the templating and everything like that. Now we're going to look at starting to create servers. So Go has a really great standard library, and everything's there. It takes a little time just to sometimes figure out how to actually implement it, or how do the different Lego pieces actually click and stack and build together. So I can build this castle of code and have it look and run, feel the way I want it to look. But here we have net listen, and it's going to listen TCP on port 9000. It gives us a listener, and there's defer close, and defer is a keyword, and it's going to close anything that needs to be closed, right? I want to put this as close to where I open it as possible, because that makes it the most readable. And then I'm like, it's easy to check. It's just good coding practice. But defer means before this function executes, whatever function I'm in, when I defer something, right before that function executes, I'm going to execute anything that was deferred. Right? Totally, makes sense. And so I got my listener, and I'm going to accept any connections. There's just a continually running loop that's waiting to see, hey, are there new connections coming in? And then once I have a connection, I can use IO copy, and this is going to write, and that's going to read destination and source. And so there's an interface, so abstract classes, interfaces like in Java or whatever. There's interfaces in Go. And so this interface is a reader and a writer interface, and so that's what copy takes. I can just command click, and I can go in here, and I can see copy, destination, source, takes a writer and a reader, and then I need to close my connection. So let's just see what happens when I run this. So I put little instructions down here. If you're looking at this code later, you're like, oh, what's going on there? So first I need to start the server. So I'm going to start the server right here in this terminal. And to do that, I'm going into 14. No such file or directory, because I have the wrong syntax. And now I'm going to go run main. So the server is running, and I'm running it from there. And then I'm going to go over to this one, and I'm going to do exactly what's said here, telnet localhost 9000. Sorry, let me just Control-C, Command-K, and let's come up a level just so it looks like that. All right, telnet localhost 9000. And okay, try and connect to the localhost, escape character, hello, hello, what's up, what's up? So I'm sending something over to the server's receiving it, and then it's just instantly writing it back, copying it back, right? So it's a little bit of an echo server. But I mean, that's, might look a little foreign to you, because hey, it's new, obviously, right? But it was not too hard to wrap your head around. And then after a couple of weeks of using it, cool, I've got that down. Let's look at the next one. So we're building on the echo server. So again, func main, listening, net.listen, net HTTP package, and we can see the, hey, how's that set up? Takes a net add thing, and then, the listening address. So that's the port 9000, get our listener, defer the close, accept, handle. So I just basically created a function here, handle, and I'm passing in the connection. And so up here I receive the connection, and the connection is of type net, package net, connection. Right, so that's a type, and I can see, oh, that's an interface. Okay, interesting. It has a read, a write, and a close method, and other stuff in there. So there is, my handle, and I'm going to do a buff.io new scanner, and then I'm going to scan, and then I'm going to scan. What's all that mean, right? So new scanner returns a new scanner to read from R, right? And so if you look at like the syntax here, I just pulled these right out of the standard documentation. R is an IO reader. And so it reads from R. The split function defaults to scan lines. So it's just reading whatever comes in, and it's going to split that on lines. That's the default. Scan advances the scanner to the next token, which will then be available through the bytes or text method. So I get like a whole bunch of stuff that comes in, many different lines, right? And then scan's going to go through each line for me. Let's scan through that, and it's kind of like a loop. And text returns the most recent token generated by call to scan as a newly allocated string holding its bytes. So I get this big text document, many different lines of text. I loop through each line, and I say, give me the text of that line, right? So cool, not too difficult. Though if you're trying to figure that out from the standard docs, that's going to be a while, unless you have a lot of experience with this, right? And so then I can print that line. So I'm going to print that just to the terminal where the server's running. And then I'm going to sprint, which is going to print to a string. So I'm just going to print that back to a string, and I'm going to add in, right, whatever I pulled off the server. So I'm going to say from server, and then I'm going to write that back using fprintline and fprintline. So I'm just kind of demonstrating some of the func package, the FMT package, and the func printline, file printline will print to a writer. So there we see interfaces in use again, and interfaces allow just exchangeable chunks of codes to be used in different places and polymorphism. And I know if you're newer to coding, those are some really big words. And, they're concepts, because I teach at California State University, Fresno State College, and they're concepts that take a little bit of time to wrap your head around. So don't hear all that. I used to hate it when I go to talks when I was learning. I'd be like, man, I understood and, but, is, or, but I don't know what those other words were. But, if you just walk through the code samples and the pathway laid out for you and just start to work in it, it's really a thing of devotion, monastic devotion and time on task. After a while, you'll be like, oh, okay, cool, that's how that works, right? So just a little note of encouragement there. So writer, and then we have a variadic parameter. And so it takes an unlimited number of any type to this empty interface. And again, don't get lost in the details here. We're doing the fast drive through the countryside with the top down, just so the general lay of the land. And you can go back later and inspect each little pull-out, take a look at the view or whatever. So that's going to write, to a file or a writer, and it's going to write this. So let's see this in action. So I'm going to come down here, and I'm going to change documents and go into 15, and then start the TCP server, and then come over here and run the server. Hello, from server. Hello, what's up? What's up? And down here, I'm also printing it to the server's standard out, the terminal, and that's that line in action right there. So we see print line, and that just prints right to standard out. We see sprint, string print, prints to a string, and then I can store that. And then we see fprint, right? Prints to a file or an IO writer, prints to a writer interface. And that's what I'm printing to here because that is a writer interface, right? So, whoa. And not all that much code, right? Like if I take out all my comments and everything like that, that's really pretty mean to set up what we just did. Let's look at a Redis clone. How many people are familiar with Redis? All right, so here's Redis. Open source in-memory data structure store uses database cache and message broker. Right? So basically, in-memory database. And let's see what it takes to build that. So same thing down here. Net listen, TCP, 9000, get my listener. Accept any connections that are coming through. Just keep looping that, so I'm always kind of like checking to see if there's connection coming through. I get my connection, I pass it to a handle func, which I wrote. And then here we have the handle func, and we defer the connection, and then we do this, okay, give me a new scanner, and then scan all the stuff that's coming in. It defaults to scanning by line, right? So I'm getting all those. They give me each line of text, right? So this is like a loop, right? That's why there's 4 in front of it. And then with each of my lines, I'm going to break my line of text that came through up into words. And so strings fields just says, hey, break this up by spaces, and this gives me a slice of the different words. I can check the length on that, right? So a slice is a list. So if my list is less than 1, that means, I have 0 words. And so there's nothing on that line. It's just like an empty space, empty string. So if that's the case, we continue, which means we just go back to the top of this loop and check again. And then we get the switch, and we're going to switch on the first argument. So my first argument for my Redis server needs to be get, set, or del for me to tell it to do something. So basically that entire chunk of code is just like, let me get the first word that whoever's connected to this server sent over. Was it get, set, or delete? And if it was get, set, or delete, then I'm going to act upon that. If it wasn't get, set, or delete, then I'm going to just do a default return to the person, and I'm going to tell them how you're supposed to use this Redis server. From server, usage, get, set, or delete, and then you can pass in, you need to pass in a key, right? And then an optional value. So if I'm setting, I give it a key and a value, like a map, right? So you'll see that in action, but I'll be able to set like fave chocolate, right? And then I'll have an entry in my in-store database, my map, which the key is fave and the value is chocolate. So then I can say get fave, and I don't need this. This would be optional, right? And when it gets fave, it's going to return back, hey, I got the value of fave. You asked for that key, and you gave me the key of fave. And when I looked up fave as the key, the value associated with that was chocolate. And then I could delete that, and I just delete key. So here I wouldn't always pass in val. The only time I pass in val is when I use set. So then I'm just going to fprint and write string, and this is going to provide. This is just redundant. So that's just showing you that hey, these both do the same thing, and so they're just two different things that you'll see when you're looking at Go code. And I just wanted to illustrate those are 2 ways you could do it. All right, so let's see it work. There we go. There we go. I'm pretty sure we're on that one. Yeah, first step. And Control-C, and Control-C, change documents, and we're on 16. Go run main. And so we just started the server, and then I come over to my terminal. Sorry, my mouse is rolling on the tilted table up here, so it's like screwing me up just a little bit. And then I'm going to connect to the server, and I'm just going to hit enter. Nothing happened. Type in something, and then I'm getting those 2 messages printed out back. It's the 2 messages just because I was illustrating, hey, you could do it with this, or you could do it with that, right? And then I could type in get whatever, and nothing, right? Or set, fave, chocolate, nothing, right? Get, fave. Why is it nothing? Because I haven't set up anything for it to do in the different cases, right? So this is just step 1, and you can see over here, actually this is step 2 when I'm talking about this at a class, but I think you guys would implicitly understand step 1. And here is how you do a switch in Go, really clean, right? Huh? So yeah, there are breaks, and fall through is disabled by default. So you don't have to, if you do want it to fall through, you have to explicitly state it. And there we go. So let's watch it when we actually add in a little logic for that. And so here, Down here we have the exact same thing, net listen, and I just repeat this because that helps learning, and then accept, and then pass in my connection to handle, and then over here I'm handling, and I get my scanner, and then I scan, and I get the text, and I break the text up into individual words, and if my words are less than 2, then I'm going to say, hey, I need at least a get and a key, right? I need at least 2 words, and then I'm going to switch on my first word. Position 0 is the first position in an index, the 0-based index. And so this is a slice, and I'm saying give me the item at this position, so I'm at position 0. And then I have my get, set, or del. And so if it's get, I'm going to get the key, and that's at position 2 because it'll be get key, right? And so I'm getting the key, and then I'm going to set, I have value equals data key, so where's value coming from? Up here, sorry, where's data coming from? Data is a map with a key of a string and a value of a string. So that's how I make a map, dictionary. And so we have value is equal to data key, so I'm creating, creating my map. And then we're going to fprint, and so we write to the writer, file printing, and that's going to send us back to the person who made the request. And we're putting a value there. And so this is a format printing, and format printing allows you to use formatting verbs, and the syntax of that is like this. So we have format string, right, where we put in our formatting verbs and then we pass in our arguments. And so it's a pretty fun thing to play with. One of my favorite things to do in class, early on, is just to godoc.org. Is to show students how do you go from base 10 to base 2 to base 16, and just showing hey, look, here's binary, here's hexadecimal. I don't know why my internet's going so slow, a lot of people, but you could go in there and you can see all of the formatting verbs. So here it's just saying, put that as a string. And then we have set, and so set is going to check to if length of my words, my slice of words, is not equal to 3, right, which would be set key value, I need 3 words, then I'm going to say, hey, I expected a value, write that back, and then just continue and send it back. And my key is going to be my second word, because the first word is the operation, get, set, or delete. My value is going to be my third word, and then I'm going to set that into my map. And then finally we have delete, and delete will just delete from the map. So you delete from this map this key, and that deletes it. And so that should allow us to basically do a Redis in-memory server. Whoa. All right, that's not that bad. I mean, I think it's pretty cool. Format, print line, and that's just the default, so let's watch that run. Control-C. Wah. And run it. Unable to connect. What did I do wrong? I didn't run it. All right, so I'm connected. I should be able to set, fave, chocolate. Doesn't give me any feedback, but I should be able to get fave. Yeah. I should be able to del fave. Doesn't give me any feedback, but now when I try to get fave, nothing there. And if I screw up, this is how you use it. So cool. All right, so that's a Redis server. This one's just kind of fun. I'm not going to go through it. You can look at this on your own, but I will run it. And there we go. So Golang. What did I do? I need to do this. What? Did I not run it? I keep forgetting that. I went to bed late. Thank you. Golang. Type a not. Okay, let's type a not, rotate it back 13. Golang. So we're on 13, just rotates each character 13 letters in the alphabet. So as you rotate, it goes 13 characters into the alphabet, and then as you rotate again, it goes 13 characters into the alphabet, which just brings it right back. Also, Caesar cipher, step 1 of encryption, but kind of cool. So now let's take a look at, we did a TCP, let's take a look at how do we do HTTP. So here we have func main, And again, right, listening on TCP, and then 9000, that's kind of fine. We're doing HTTP, but we're listening on TCP. That's just the way you do it. TCP is beneath HTTP on the network, and so we're going to be able to do HTTP on top of TCP. That's the way it's just all set up. I know that doesn't make a lot of sense if it's new to you, but you just kind of at some point say, okay, all right, you can't know everything as a developer. You just have to like, okay, that's the point where I just assume everything beneath this works. Server accepted the connection, and then pass the connection in. And here I change it from listener to server, because now, hey, we're going to do an HTTP server. So don't let that switch in word change you. This isn't a keyword, or it doesn't mean anything, it's just a variable. And then handle connection, defer the connection close, and then I'm going to do a scanner, and then I'm going to scan, and I'm just going to print the text. So if we go here, right, and again, I give you instructions down here, go to your browser. So we're going to start it and go to your browser, go to localhost 9000, and then in the terminal server, right, we'll go look at the request line and request headers. So we're just going to see that when somebody goes to our server from a browser, we're not going to get anything back as the client making the request, but the server is going to register the request. Again, step one, just make sure it's running. So the first thing we need to do is start it. Which is not that command. That's a long file name. Okay, so we started it, and now we just need to go to, in our thing, localhost 9000. Nothing, right? Just see it spinning. But if I look here, I registered the request on the server, right? And then you'll see all this stuff, and we're going to learn just a little bit about that, or not. Man, this time goes quick. We're not going to learn anything about that. You can learn about that. We will learn a little bit about it. So, this is sort of the basics of web. Client is a browser. They make a request. That request comes over. It has a request line and headers. And then the server receives that, processes the request, and writes a response, which has a status line, headers, and content. Right? And that's not normally my desktop background, but I knew I wanted to show that image at some point. So here we have, wow, I wish that image, let me do it this way. Silence. I feel like it's a radio show. Dreaded silence. I thought I had that image here. I don't. That's all right. So here we have the status line, the request line. Here we have the request line, right there, request line. And here we have headers, and headers are key value pairs. Okay. All right, so that's the first step in an HTTP server. And where that's a 0 step. That's just showing us the request line and the headers. Now let's look at the next step. And the next step is, again, same stuff with the listen and handling the connection, and then a scanner, and then we're saying I is equal to 0 here, and we're checking if this is the first time through the loop. All right, and then we're going to increment, we're scanning, and we're getting each line of text, and we can print each line of text to the server. And if this is the first time through, we are getting this request line, right? The first time through, that's that first part in our header. So right here, that's the request line right there. And what we're looking for is get, right? Because once we get that word, we can start to do some logic based upon that. And so that's part of building web apps. Is this a post or is it a get? And we check that. And so here's the first part of doing that. So we get that first word right here. And we say, hey, this was the method of the request that came in. And this is print line, so this should just be printing right here to our server's terminal. It's not going back to the client. And then we increment this. So as we loop through all of the different lines that are sent over, we're only operating the first time on that first request line and getting that first word. And then we're printing it. And it's going to occur, this line comes through, and it gets printed. And then we grab the method, and we print the method, so we're going to see the method appear up here, and then we loop through and print all the rest of the lines, the headers right there. So let's watch that happen. And I feel like I have way too much open. And I said it's something else. All right, so, oh, wrong one. My apologies. Right here. I'll close 9,000. So that now should have sent this over. And we printed this method get, right? Cool. All right, so the next one, building a server from scratch. That's what we're doing. What changed? So we're printing that method, and then we're going to have a little bit of a break here when line is equal to nothing. We have an else here, right? So we have some else condition, and I think in the next one, we don't do anything okay, we're starting to do body. And so down here, we're doing a response. Now we're writing back to the client. So we create something we want to write back to the client. We're going to create our headers. And so up here in this picture, this is going to come back on me. All right, we're writing back the status line and then the headers. I know there's some shortcut for that. I don't know. I'm still a year new to the Mac. And so that's where we're writing back, that stuff right here. And here's our header, one of the headers we're setting. And then we're going to write the connection. We've got to do a return in a new line. That's just part of the syntax. And then we're going to write the body, that text. So let's see that run. And this is 21, so Control C. Get into my terminal. Control C. Okay. Change directories into 21. And then come over here, and come over here, and bring that back up into view.
It's not running.
Huh?
It's not running.
I didn't start it again. Thank you. And start it. Hello World 2. All right, sweet. And if we take a look at that, we could come over here and we could see, what the headers were that came over and everything like that. So the request, right, and then the response, content length. And if we look at what did we do here, content length. So we set a header right there. Pretty cool. And I think I might have a cookie set from when I was working last night for localhost. Let me just clear that because we don't need that yet. All right, that's 2021. Let's take a look at 22, and we'll just run it and see what the difference is and look at the code. So this time we pass back, a bunch of HTML text, right? Well, that's cool, but it came through as text. And the reason it came through as text is because we said, hey, this is text plain, right, as our header. So let's go back here and look at 23. And we'll come here, and now we'll hit refresh. Hello world, and now if we look at our header, text HTML instead of text plain. Cool. Whoa. We just created a server, and we received a request from a client. We did some processing on that request, and then we served a response back to that client. We set our own headers. We were looking at, sorry, this is annoying, I wish I had that image. We were looking at the request line and the headers, and we set a header, or we interpreted the header that came from the client, and then we set our status line, and then we set our headers in the response, and we gave it some content. Pretty cool. And, not all that difficult in terms of the syntax. If you're new to it, it's a little bit to wrap your head around, I know. So that's 23. And just because we're running short on time, 21, 22, and 23, you've seen most of the fundamentals of how those things work. And then there's just like changes, like in 23 here, we added in that, and then we changed this to content type. So that's 22. We changed this to content type text HTML, right? So it be interpreted by the browser as HTML, as opposed to just plain text, right? So the browser looks at that header to figure out how to display it. Like I said, right, you're looking at the engine for BMW 528i now. old Model T. And so then, okay, well that's, a little bit rough still. It seems like we could abstract that a little bit more, just make it a little bit more smooth. I just want you to see, how do I do it myself? That's why I put DIY, do it yourself, build an HTTP server from scratch, right? And just reflect for a second what you picked up here in 2 hours. You've seen how to do all the templating, right? And actually kind of create web pages dynamically. And now you're seeing how to build your own servers, right? This is like, Apache and PHP all at once. So here we have something called a servmux. And so before we were doing it like this, right, where we built a server from TCP, right? We said, hey, here's a server, it's listening here, and then we're going to accept connections. And then once we get a connection, we're going to do something with it. We built that server from TCP, or you could just do this. And if you go into the standard library and look at like how they built it pretty much just like we built it. But obviously there's a whole lot more of your checking and things like that. We saw the stripped down version. But listen and serve is going to create a server for you. It's going to listen on port 9000. It's going to use a mux. A mux, what's a mux? Well, there's two words that can sometimes be confusing to new people. There's a mux and then there's a mutex. Right? Pretty closely associated. One only has 2 more characters than the other. So mux is a multiplexer. A multiplexer is let me help you choose a route. Right? That's kind of an engineering term. And then a mutex is a mutual exclusion. And that's for when you're trying to prevent race conditions. And so we're creating a mux, which is a multiplexer. Help us choose different routes based on is it get coming in, is it post coming in, is it this URL or that URL. And so here's my mux, and I use a function that's attached to mux. And so if I look at the standard documentation, right, like I come in here and I could see that mux has a method handle func, which is going to take basically which URL. And then based on that URL, I can tell it to run a certain function. And the function has to have a certain signature. It has to have a request, receive a request, and a response writer, right? So those are the 2 parameters or the arguments it takes. And when it has this signature, it is a handler func. So handle func takes a handler func. And there's a way you can also set this up with a handle and a handler, right? And that's all explored in the other resources I gave you, but I've just kind of skipped one of the big, like let's build it up from scratch DIY and jumped right up to the handle and handle func and handler func. And so I create my new mux, and it's a HTTP new serve mux, and then I just say, hey, these 2 places, I want you to listen. And if a response comes in at this URL, we're going to run uptown. And if it comes in at this URL, we're going to run you up. And I don't know, I was listening to Funktown Up You Up or whatever that song is, probably when I wrote that. And let's go look at it, because this is awesome. And so now I go to my browser and just hit refresh, and nothing? Oh, dang, code crash. What did I do wrong? Cool, I don't know why it just kicked in. I thought that was actually going to be a joke, but then I realized, wait, no, something isn't quite working right. It should be serving at that default. So the default, right, just nothing, doggy, 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 doggy. And then with the / cat, right, catty, 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 whoa. RESTful web API, right? And no files here. I'm not like serve this PHP file, index.php or whatever. It's all based on just coding, logic in the code. This path comes in, run this chunk of code, all right? RESTful web API. And here, if I do anything else, it still serves cat, right? Because here I have a / and that means catch everything after cat. If I took that / away, right? It would no longer catch everything after cat. It would only specifically catch cat, right? So this went to doggy, doggy, doggy because this is catching everything, right? But when I go back here just to that, catty, catty, catty. So that / is just one of the things that, hey, let me catch everything. That's beyond this. Catch it with that one path. And so that's how that works. So let's look at the next one. And what is the next one doing? Default serve mux is the next thing. So we, did that thing here where we were creating HTTP new serve mux and saying mux and then passing it in here. Or we could just say nil, and it automatically uses the default serve mux. If you look at the Go doc, let me see if we have internet and library for net HTTP standard library, and look at what's a default serve mux, right? A default servmux is a variable that's in the standard library, so you can only use functions and methods in the standard library, but also variables. And default servmux is a new servmux. Oh, cool, right? And if we look at the listen and serve, right? HTTP listen and serve, right here, it tells us if it's nil, default servmux is used. The variable default servmux is used. So right here, pass a nil, default servmux is used, and that does exactly what this did, right? Create a new servmux, and that's what we use. So that's, oh, cool. You know, you kind of got to trace things in the standard library. What's up?
If you would accidentally break the updown function with the wrong signature, how would catch that?
Oh yeah, absolutely, yeah. Yeah, no, the compiler suffers no fools. But it also has very good error messages, right? So it would tell you, you know, in Go language, for talking about the language. So once you've learned like some of the different words we use, you could read that. So the next one is we're going to use IO copy to serve a file. And so here, you know, is listen and serve, port 9000, nil. I've got 2 endpoints which I'm catching. One is for Uptown. If anybody comes in at anything, we're going to run Uptown. Uptown is going to this function, right? It's got the handler func signature, and it's going to set a header, and then it's going to create a variable dog name of type string, and then it's going to split the URL path, everything. It's going to split it on the slashes, right? And so if the length of the fields I get, the words I get, is greater than or equal to 2, because here at my URL, the first slash right here, it gets the space right before it, that's 0, and the space right after it is 1. So if I put this in, at position 1 I would have cat, at position 0 I just have nothing, so it's going to split, and then if I have this, right, at 0 I'd have nothing, at 1 I'd have cat, at 2 I'd have DFG. And so I'm splitting on that, and I'm getting those fields, and if I don't have if it's not greater than or equal to 2, the length of that, meaning I got this 0, 1 is the first one, and that one is the second one. So if I don't have at least 2, then it's not going to run this. Otherwise, it's going to set dog name to the second one. So the index 0 is that one, and this is 1, 0 base index. And then we're going to write, which writes to a writer, and that's going to be the response, which it writes to. And we're going to write the dog name, right, up the top, and then we're going to serve the image. But this image isn't going to serve because we haven't set up serving files yet, and we're going to see how to set up serving files in just a second. So let me just go ahead and Control-C that, and change directories into 26, and then go run main that, and I'm just making sure that that's everything. And so localhost, and I'm just going to do nothing. Oh, hey, did serve file. I don't know why that happened. I got to look at the code. I didn't think I had that set up. But I could also do this. And it grabbed something from the URL and, you know, use that in building the page. And, you know, as I change it, it changes, or, you know, it's that argument in that position. Tubes. Just tubes. It's just getting that one position right there. Why did that image serve? So maybe a little code troubleshooting here. Toby serves dogpic. We didn't look at this. So dogpic right here, we're going to open the file, Toby. So this is kind of the rudimentary way to do file serving. Again, showing you how to build it up from scratch. Open up the file Toby, which is right here, and then catch any errors and defer the close, and then just copy that file to the response. Right? So when something comes in at this request, that's what runs, and it comes in at that request right here because when this first one ran, it said give me this, and so it asked for that, the browser asked for that, made another request to the server. That request came in here, and then we served that file. So I'm just a little bit mindful of time. Sessions are supposed to go till when? Top of the hour? Is that right?
Yeah, 75 minutes.
75 minutes? Oh, so we go till 12:15 or 12:30 or what? 12:30. Cool. Because there's a lot of stuff I want to show you, and I thought, oh, I'm out of time. We got to 12:30. Great. I'm really glad to hear that. All right, so that was copying to serve files. Now we're going to look at using something called serve content, and then we'll look at serve file. and then we'll look at serve files, file server, sorry, right? Which serves just like everything. And so just different functions in the standard library that you can use to, serve your stuff. And so this is serve content. And so before we had dogpick, which was doing opening a file and then deferring to close and then getting file info, right? So we got some file info, and then serve content is going to serve all this. Because the problem with this here, this code here, this is the way we did it before, just copy. Like we're just copying the file over, and that's all that's getting sent over. We're not sending over any E tags. We're not thinking about like performance and like, do I really need to send this to the client, or do they already have the most recent version on their cache? Right. So serve content also allows you to pass in the file name and the last modified time. And I don't use serve content, so I'm not completely familiar with it. But that's what it's doing. It's giving more information to the client making the request to determine whether or not we even need to send the file over. And so that would do the exact same thing we've already seen, so I'm not going to run that. And serve content is just like nice to know about, not necessarily something that you'd run. So then, what's this one doing? We've got serve file. And so all of that got condensed right there, right? Like I didn't have to open the file, defer the close, all of that stuff. It's just, hey, serve file. Which file do you want to serve? This one. What's it take? A response, a request. There's the file. All right. So it's checking the request, seeing what kind of information I have, and and again, so I'm 9 months new to the language, but I believe I don't have certainty on this. I believe this is also checking all that stuff about E tags and do I need to actually serve this back and everything like that. I have like 97% certainty that that's what it's doing, not absolute. You have a question?
What do you do debugging?
Yeah, so debugging, that's a really good question. Testing and benchmarking, and you could do breakpoints, the whole thing. My mentor, really recommends like stay away from the debugger. Don't use the debugger. Like just look at your errors and your stack traces, and everything like that, and you should be able to do everything you need to do just straight from that, and you should understand all of that. So yeah, but that's all something that you can do, and not something we're covering today, but definitely available to you. All right, so where are we? We just looked at serve file, and that would also just show us the exact same thing we've been seeing. So we're just seeing different ways to do it. And then here we have file server, and so we've got handle, and then handle is doing a file server for anything at our root directory, right? And then we have dog, which runs uptown, and we have our server port 9000 using default serve mux. And so when something comes in at dog /dog, it runs uptown. Sorry, I was looking for dog up here. So uptown sends a header, we get the string, we're getting the name, and then we're just printing out the name. So we already saw that. And then when anything else comes in, we're just serving the file. So file server returns a handle that serves HTTP requests with the contents of the file system rooted at root. So let's, this is kind of cool. Let's run this. Sorry, I went to the wrong one. And go run date. Nothing. Just go to root and see what happens. Whoa. Got my files. Whoa, it just served my main file. Right? Or, right, it's serving everything. That's kind of cool. It served the whole deal. What happens when I go to, I had that one path set in there, /dog. Right, so it actually executed this code right here where we wrote, a response. And then if I add in Toby, but like, whoa, that's really cool, man. Look at that functionality. Hey, what's up?
Concurrency, multi-threading.
Yeah, concurrency multi-threading also really great, and that's like, that would be hour 4 of this presentation, and we only got 2. So we'll see a little bit of that, but I gave you the resources to learn as much as you want about it.
It's like Python, single thread.
Not at all like Python. I don't know, I've only done a little bit of Python, no web Python, but I do know that it's twice as fast, or even more, because it's twice as fast as Node and 4 billion times faster than Python. I just made that number up.
Is concurrency part like Java 8?
Concurrency is baked and it's part of the standard library. It's totally easy. Atomicity, mutexes, channels, it's all there. It's super simple. We'll see a little of that, but it goes known for concurrency, but it's a higher level deal, and I just sort of wanted to provide today, like up and running with Go, building web apps. And so this pathway you're seeing today are those two things, and also the resources I've given you, including Bill Kennedy's book, which is the best place to start when learning about concurrency and everything. You can get a free copy of that, so after the presentation, come up and enter your email, and we'll email you a copy of that book, or Bill will. Okay,
If I put dot dot after 9,000 slash,
right here.
oh, okay, so Bill gets some security. I'm just curious.
Yeah.
It was a dog slash code, say dot dot.
I had to hack this.
Oh. Interesting. What happens if we keep going? I don't know. You guys can play with that later and then make a video and send it to me. Like, hey, look at what I figured out. Is this a cool hack? Or this is how you hack it. This is how you prevent it.
Yeah.
So that's file server. Here I've taken file server and I put things into assets. Right? So something you want to do. The syntax for file server gets a little wonky and takes a little time. So here we did well that's that one. Before we did it like this. Cool, file server, just at root. All right, so I ask for that, and it gives me that because that's where it's at, right? But when I have it in a different location where I'm asking for it, where I need to get it, are two different places, it takes a minute to wrap your head around it. I still have a little bit of a hard time like explaining it, but this is basically what it does. And so let me just zoom in on this because I said I'm just going to write this out because I'm going to take time to like explain as clearly as possible. And once it's written out, I won't have people could read it and go back to it. I could just read them and telling people about it. It's just gonna. So here we have HTTP handle, right? And before, the handle was just like that, right? But now the handle is with all of this stuff, which is HTTP strip prefix assets. So it just looks kind of like, oh man, handle assets, strip assets, serve to at what the heck, right? So we ask for assets Toby here. That's what we're asking for. This matches the routing on line 24, right? Oh, anything that comes in at assets, and this is catching everything. This catches everything after assets. Anything that comes in at assets, this is how we're going to handle it, right? So when we ask for that, it matches this line of routing. The file we want is called Toby JPEG, right? This is what we want to serve, not assets Toby JPEG, right? The file, that's the path of the file. The file we want is just Toby JPEG. We therefore need to strip assets from what we've requested. So we requested, this location, but really we just want this file. So we're stripping off. I know, right? Just take a second to wrap your head around. We're stripping off assets from here. And if you look at the documentation, strip prefix returns a handler that serves HTTP requests. So you'll get that in a bit by removing in a couple of weeks, by removing the given prefix from the request URL's path. Removing the prefix from the request URL's path, that's an important part. So that's what's happening. So here's the request URL's path right here. We're removing the prefix. This is the prefix we're removing. So we're leaving / Toby JPEG. So we removed that. All right, so we therefore need to strip assets from what we requested. URI assets Toby JPEG. This leaves us with just / Toby JPEG. The file server then looks in assets, right? Starting in our root, you'll look in the folder assets for / Toby JPEG, which gives us assets / Toby JPEG, which is exactly what we want. I know it takes a while to wrap your head around, but that's the best explanation I can give. So just come back and reflect on that and use it some. And like I said, it's still not totally clear to me to explain it, which is why I typed it all out. So when we do that, it's going to serve anything in the assets folder because before we were serving our entire site. What happened to my project? There it is. And we're looking at 30, which has that. So let's close this and change directories into 30. go run a thing, and then go look at it. And that's the last thing I'm showing you from that presentation, so I can get rid of it. Just do it here. Plus 9,000. Why is it giving me everything? Funktown, Uptown, 30, 30, 30, main.go, Uptown. I don't know what just happened. Oh, I was pulling something from cache. Dang that cache. There's two hard things in computer science: naming variables and clearing cache. That's somebody else's quote, not mine. All right, but so there we're serving that file. All right, we can still do the grabbing things from the URL. So how many people are feeling a little bit mind blown? Anybody? Like a little bit overwhelmed? A little overwhelmed, yeah. But also like, okay, not too bad, right? Not too bad. So don't be discouraged, right? Like it is, like I said, hey, here's the BMW image engine. You are going to know how this engine works. You want to be a mechanic of BMWs, you need to know how the engine works. You want to be a mechanic of the web, you need to know how the engine works. Right? And I know this isn't like Ruby. Somebody's like, man, with Ruby, we got Rails, and I just stand it up, and boom, 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 and like, I'm having coffee. I'm like, yeah, but that's like showing up to the barbecue, right? It's like you don't get to choose the location, you don't get to choose the drinks, you don't choose what's going to be cooked, you don't get to choose the guests. You show up, you have some good food, it's a good time, it's easy, you leave, nice, right? But if you really want to like, control everything. That doesn't sound so good. Bad. But if you want to understand the internals and be able to customize it and most importantly, because that's not the biggest selling point, most importantly, handle whatever is thrown at you. Facebook crashed so many times last week, right? Like you want Facebook not to crash? Right, go. Or you want your thing, whatever it is, not to crash? Right, go. Because it can handle it. That's a better analogy. All right. So that was, we saw that one, that deal, that was 30, we just ran that. And we're getting close, I think we're doing all right since we have till 12:30. So then we have one more take on that. I'm not sure what the difference is here, so let's just run it and see what happens and then we'll figure it out. Slidey table is annoying me. I apologize for that. Yeah, fire away.
Yeah, so if the code that you write is actually the same, if you're going to be serving 1,000 local users, that same code could be there to serve
1,000 or a billion. Which one what's the code? This is the starting point. Yeah, but this is, yeah.
That's all you need.
That's it. Yeah, it's all built in. Yeah, by people who are smarter than me. I'm not sure where you register on that scale, but so good for them. So let's just see, I didn't see a difference when we ran this. I want to see what I did. Oh, you know what I did on this one? Is here, I named this different so we could kind of, no, those are the same. What did I do on this one? Here I named this different so you can kind of see, I feel like that helps distinguish it a little instead of assets, 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 resources, 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 in folder assets. So I thought that might help clarify it. So you could process that one later too. I'm giving you guys a lot of stuff to take home and think about. All right, whoa. I like doing that just to see everybody look up. Whoa. One line of code. I've got my static file server. I don't need to catch the error here. I can take this off and it'd still work, right? If there was an error, like catch it and then just log, hey, we had a fatal error. But so let's just take that off and I'll look a little bit more simplistic. I kind of was debating that last night. You can't have crap in your code you don't use. That's a compiler error. The compiler says, dude, you left some garbage on the table when you're working. Pick up after yourself. We're writing clean code. You want to pollute stuff? Go back to Python. Go back to Node. Go back to Ruby. Sorry, I can't help but to have a little bit of fun. So, right, listen, serve this port, file server, everything in root. And my static site, I'm kind of excited about this. We've been down a long road together as teacher-student relationship, and finally we've reached this point, and I need to run it, and it'd help if I ran a file. Let's go. Nice. Static site. This is the summer web boot camp we put on. Here are the speakers. Ryan Bonhart, awesome. Ray Villalobos, awesome. I think Villalobos means Wave the Wolf. Like, how cool of a last name is that? I'm like, dude, you got the coolest last name ever. Wave the Wolf. Super nice guy. If you guys, I'm just going to plug Ray, okay? If you're in a corporation and you ever need training and you want to bring in a trainer, hire Ray. Just super friendly, super smart, like so totally good guy. Like the last day of the training, we had him in for 3 weeks. He's like, I want to buy you guys all pizza. I know that's not a big thing if you're in a corporation, but when you're a student at school, that's a really big thing. And the fact that, you know, it's only $100 or something out of his pocket, but he was the only guy, right? He's like, let me buy you all pizza. Come on, let's have a party. 3 weeks. Studied JavaScript. We had a great time. So, you know, fantastic dude, lynda.com. And then Zeno Rocha also, and Zeno is like so inspiring. I feel like that picture just says everything about Zeno right there. You know, just like love of the game. Like that guy codes until he falls asleep at his desk, wakes up 10 minutes before class, comes in unshaven, messed up hair, unkempt, and then blows your mind for 8 hours straight. You know, Zeno is awesome. And Caleb Doxey is like, you know, triple third-degree black belt ninja of Go programming. So if you ever like are stuck and you need a consultant, like just get in touch with Caleb. Also Bill Kennedy. You know, both those guys are like amazing. So he was with us for 4 weeks, and he's the guy who helped me. You know, my two mentors, Bill Kennedy and Caleb Doxey. I mean, it's hard to be a teacher because there's a lot of other bull crap you got to deal with. Some of it really important, some of it bull crap like committees. You know, and then you're doing all your teaching, but then okay, I'm not coding every day. You actually have to like, I got to get my 2 hours in just to stay current and keep myself busy. Otherwise, before you know it, you know, it's 2015 and I'm still teaching students Flash with ActionScript, and they're like, why are you teaching this? So that's why we put on this boot camps, just to try to bring teachers up to speed, including myself. And we gambled and kind of tried to go a little bit more cutting edge, like what's coming. We want to learn what's coming instead of what's here and will be gone, right? So that's standing up a static file server. And then you could take that, and we'll see how you do this at App Engine, but you could upload, there's Google Developer Console, which takes you to sort of the developer console for App Engine, right? And then in here, you can upload projects. And so Web Programming Summer Bootcamp, right? This is running on App Engine. It costs me nothing, right? So that pretty much same code you just saw is now deployed to domain. So I go to Google Domains, and I purchase a domain. Like this is the point where you're just like, bam, 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 bam. Whoa, I got a website up and running. So awesome. I know HTML, CSS. I know some JavaScript. Here's my static server. I get my domain at Google Domains, right? And I come into Google Domains, I configure the DNS, and in the DNS, all I do is I point it to my App Engine, you know, Developer Console ID, fresh rain, right? Whatever the heck that means, it gives you one. So here's my Developer Console, you know, and that's the ID, the project ID. So I point my domain to that project ID. I upload, go deploy, or it's not go deploy, App Engine deploy. I can't remember the command right now. I don't use it all that often. But, you know, then bam, my code is up, running at a domain. It costs me $12 a year for the domain, right? And if I get a lot of traffic, then I start having to pay, but no big deal, you know, so that was totally awesome. Google Developers Console, set up your App Engine project ID, create a new project with the ID, go over, grab your ID, configure the domain, point it towards App Engine, right? And your clients, you're paying nothing to host your clients' websites. You're billing for clients, you know, until they get a certain amount of traffic. Totally cool. So next we have setting cookies, getting a cookie, getting rid of, you know, another request from favicons. So when a request comes from for a favicon from a client, handling it, doing sessions, creating state, logging in and logging out, doing a HTTPS, which TLS is the successor to SSL. Right? SSL is the predecessor, TLS is the new one, Transport Layer Security, and then let's create a photo blog. So that's in 15 minutes. And preview the photo blog. So we'll just start there because it's getting towards the end, and I think you guys have been focused for quite a while, and you need a little bit of like keeping going. So there's the photo blog, and just go to localhost and see what happens. Cool? Cool. I just created Instagram. Kind of. It needs a little formatting. I need to bring in a front-end specialist, a little CSS and HTML, right? One of the guys at the boot camp did such a nice job. We're like, dang, that's awesome. And this is a very specific skill set of knowledge. Few people in the world know how to do this. Even fewer know how to do it well, right? Like this is the way you should be doing it now, unequivocally, with confidence, putting hours of my life behind this statement, right? This is the way you should be building web apps today. This framework, this stack, right? This language, no hesitation saying that. Like, and what I do for a living is I just try to stay current and I study. I study this stuff and then I teach it. And everything I've studied, this is the way to do it. So if I go to admin, ask me for a password, secret, and I can choose a file, and I can upload a file, so I don't know what is on there or not on there. I don't think I can see the page it's hit. So we'll just do this girl at the surfboard again. Maybe that's not on there yet. And you submit it, and kabam. Whoa. So we'll see that in a second. Alright. We left off at setting a cookie. So that's it. Anything that comes in, I'm going to run this function, this handler func, and it has that signature, which makes it a handler func, and then I'm going to use from the net HTTP package or the standard library the method set cookie, which is going to take a writer, it's going to write to the response, and it's going to point back a cookie. This is giving me a pointer address, right? And so if that's foreign to you too, really good things in the pathway that I've given you to understand pointers. You'll always pass by value in Go. Don't talk about it as reference, dereference. Okay, occasionally you can use those words. But it's just always pass by value, and sometimes the value is an address. Okay. The name is as my mentor, I know Bill likes to say a lot, if you do this, when you do something wrong, we're going to take a walk. If you start talking about it like Java, we're going to take a walk. So here's the name. So I set the name of the cookie and then a value, right? And I give it a value. And so let's just see that. Because, when the book and the bird differ, believe the bird. And it's always kind of cool to see that it actually works. I had a friend one time who was like, it's kind of weird. I think about like all this time we invest into studying this esoteric thing. And like, if apocalypse happened and it's like zombie apocalypse, like everything we know would be completely useless. It's like, I don't know how to live off the land. So let's look at that. Just hit request, and what we should see in resources now, a cookie got set. There's name, my cookie, value cookie monster. And if we look at this, we should be able to see over here some interesting things. So which one is coming from the client, the request or the response? The request is coming from the client. So the client made a request, and is this off the screen? And I think I hit refresh a couple times because it sent the cookie over when I was making the request. If the cookie wasn't there, and I make the request, right? No cookie got sent over. There's no cookie in there. But when the response was made by the server, the cookie got sent over. And then when I make another request to the server, cookie gets sent over because it's now there. Yeah, cool. So that's how we start to track state. The web is stateless. If you get into talking about REST, they'll talk about representational state transfer. People will have different ways of thinking about that. But it's stateless. A request comes to the server fills the request, and there's no ongoing persistent connection unless you're doing WebSockets or something, or WebRTC. So how do we maintain a connection with the client? Well, I need to give you a unique ID. Every time I pass something to you, and every time you pass something to me, you give me a unique ID, and then I can take that unique ID, and I could say, do I have any information for this person, this unique ID? And oh yeah, look, they have this account with us, and they're logged in, and here's all of their posts and pictures, and I can now take that information and build a custom page for them. So that's setting a cookie and maintaining state and starting to build sessions. And so this next one is getting a cookie. So Control C, 34. And I need to be here. Make a request. So what did this code do? I got the cookie and then I wrote it out to the server's terminal just so I could say, hey, the client sent me a request. There's a cookie with it. I got that. And I have that value and I was able to do something with it. So that's what allows us to start to, oh, I got a cookie. Let me get the unique ID. Let me check the database. Right? But here it's format print line. I just printed that to the standard out on the server. And so I was just seeing what's in that cookie. And you might be like, yeah, Todd, but what's with the doublespeak? Right? Well, if I look at what is coming, right, I get 2 requests from the client. They're requesting localhost and a fave icon, which is this little thing up here, which I've got a fave icon for you. So I say in the next one, I don't have a fave icon for you. Don't give me doublespeak, right? And so when they ask for a fave icon, right, I just say we don't got that. What? Oh yeah, so you have multiple returns in Go. Thank you. And this one would normally be the error. Right? And then I check for the error, but if you want to throw something away and not use it, you explicitly have to tell Go, I know I'm supposed to get something here, and I'm not going to use it. And you do that with the underscore character. So you got 2 returns. And so I just wanted it to be no pollution in you learning some of the fundamentals. So now that I have my fave icon bye-bye, those are my words, that's not official Golang idiom, speak, whatever, the language we're talking about the language, and run it. And make a request, and okay, they get back that, or whatever that's happening, but only, it's not coming in here. Right, I'm handling it that path, I'm not handling up here where these get printed, right? So they ask for a cookie and I send back not found to them. All right. So that's just like, one of the things that at some point as you're doing this, you'll be like, what the heck? And then now it'll be like, oh yeah, that's what that does. So here we create sessions, and I'm not going to go into a lot of detail about this code or run it. Totally I could, but you really want to see it. But here, same thing is just, at anything that comes into the server, we're going to run this handler func set cookie. And we have a new package, which is not from the standard library, so you'll notice the import has a naming space convention to keep things unique. GitHub.com, so domain, username, package, right? Standard library, you just specify the package. And I request my cookie with session ID, get the cookie, and if the cookie is not set, so if the error is nil, so here we're checking the error, right? So the error is non-nil. There is an error, it's non-nil. I create a new UUID. A UUID is a universally unique ID. And then with my cookie, I write that ID, and I can add whatever else I want to it. And then I set that cookie, and then I'm printing that cookie in the server. So actually, let's see it. Royalty table. So if I look at my resources, my cookie, right, and I have this crazy cookie call with the name of session ID and this value, there's my unique ID, and I put other things in there separated by spaces so I could parse it if I wanted to. And then on localhost, right, I could see, when I've made my request, I only had this cookie, and then the response came back and it gave me that cookie. You can see what happens if we ask for another one. Now it passed back 2 cookies. So I have 2 cookies on my machine, and the response header passed nothing back because you already got the cookies. And they're the current ones or whatever. So that's sessions. And then there's this entire thing about HMAC. And, cookies are editable. You could open up a cookie, edit it, and then change it, and then make a request to the server. And so if I use Wireshark and I'm watching network traffic somewhere, I could see maybe people's cookies going across as over HTTP because they're not encrypted. And then I could grab somebody's cookie and I could take that ID and I can make a request from my own account and I'm in whatever server they're at under their account. Well, how do you prevent that? You need encryption, right? You need some sort of encryption. And so HMAC is a hash checksum, like hash checksums. So this is the best example for understanding HMAC. If you're not familiar with checksums, you go like when you download this program, when you download the Go SDK, right? Here's the checksum. And it's a crazy number, but a hash is just like some algorithm you run against a bunch of code or anything, any file, and it looks at all that and turns it into this number. And anytime you run that hash, you're going to get the exact same result on that file, unless you change the file. If you change the file with 1 comma, you get a completely different number. So when I download this thing to install on my computer, I could run SHA-1 against it, and I could get SHA-1 on my computer. Same algorithm that they ran when they got SHA-1 and said, this is what you get when you run SHA-1. If I get a different number, I know the file I got was not, the file I received was not the file they intended. And okay, somebody tampered that, I'm not going to install it. So that's like a checksum. We're doing the exact same thing with HMAC, right? And it's, just allows you to sort of make sure what you got is, what you received is what they sent. And so that's how we can know if somebody tampered the cookie. It's complicated. I don't even know how to fully implement it. Instead, you're going to use Sessions Gorilla, right? Which does all of your HMAC for you. So if you look at Golang Gorilla, they have sessions and secure cookies. And so Sessions uses secure cookies, and so secure cookies does all the HMAC stuff for you. And then Sessions allows you to implement sessions, and you do it in this way right here as an example. And then when you do it, you also need to use context clear handler. And so I have code samples of all that, and that will just prevent any memory leaks from happening. So anyhow, that's how you implement sessions. And then for log in and log out, because we got 2 minutes left. It gets a little bit more involved. So I think we got pretty close to getting through it all. But we have log in, log out, HTTPS, TLS, and then the photo blog code, which if we had another half hour, I'd totally walk you through all that and we'd see it. But I certainly think you've got a full plate and plenty to chew on. And once you've chewed on everything I've given you, you can come back and look at this code on GitHub. It's going to be here. Read those other resources. And you're well on your way to quickly becoming productive with Go and doing stuff with Go. I mean, like right now, you can start putting together static sites and putting them on an app engine and using Google domains, and cool, man, it's running. So, yeah, questions? Well, let me just say before you go, if you want that free book, you can come up at any point, and I'll just continue to answer questions. And enter your email. And before you do that, to everybody watching online, thanks for joining us. I hope you learned something good, and I hope this is helpful to you.